When we say we want exact trigonometric values, that means we want values that aren't like their decimal equivalents or something like that. So for sine of pi over 3, this is a number, okay? We just need to figure out what the number is, and I'm going to show you like a strategy for doing that. Before we do that, remember this is in radians. To convert from radians to degrees, take the radian measurement, cut the pi out, and then multiply by 180. So if you do that with a calculator, that's basically 180 divided by 3. So pi over 3 is a 60-degree angle. So sometimes it helps to first convert it to degrees. But what we want to do is consider two different types of triangles when we're trying to find exact trig values. Okay, these are the ones that we usually have students memorize. These triangles in this approach won't help you find exact trig values outside of these situations. But if you have a triangle that has 90 degrees, because we need a right angle for right angle trig, and we got 45 degrees and 45 degrees, what we usually do is we draw this triangle in the unit circle so that the hypotenuse is 1. Okay, because remember the unit circle is a circle with a radius of 1. And so if this is 1, then by the Pythagorean theorem, since these are both 45-degree angles, we know that this has to be the square root of 2 over 2, and then this has to be the square root of 2 over 2. Okay, and then you could do the same thing over here. If you let this be 1, you could use right angle trig to do this, but there's 30 degrees and 60 degrees, and then this would be pi over 3. This is 1/2, and then this is square root of 3 over 2. So if you memorize these two triangles, they'll help you find exact trig values without having to go look them up or anything like that. And then additionally, if you plug in sine of pi over 3, it gives you a decimal equivalent in the calculator. It doesn't give you the exact trig values. So here's how to use these triangles to find the exact trig value. For sine of pi over 3, we said that was 60 degrees, right? So that means we look from 60 degrees perspective in this triangle that we memorized. Sine is the opposite divided by the hypotenuse. So our sine value is the square root of 3 over 2 divided by the hypotenuse, the 1. In other words, sine of pi over 3 is the square root of 3 over 2. Okay, let's do another one, because that still might not make sense, and that's okay if it doesn't. Sine of pi over 4. If you convert that to degrees, I think that's going to be 45, right? Cut out the pi, multiply by 180. So if you multiply this fraction by 180, it's basically dividing by 4. So we got a 45-degree angle inside there. So that means we use this triangle. So look from either 45 degrees perspective, okay? Sine is the opposite from the angle, which is square root of 2 over 2, divided by the hypotenuse. So sine of pi over 4, the exact value, when you simplify that, it's square root of 2 over 2. Let's do cosine pi over 3 and find the exact trig value here. Pi over 3, that's a, we said pi over 3 is a 60-degree angle, so we look from this angle's perspective. Just remember that cosine is the adjacent divided by the hypotenuse. So the adjacent is 1/2, and the hypotenuse is 1. So we divide by 1, so it just makes 1/2. Okay, so these are the basics. I think these are the first types of questions you're going to be asked. Later on, you're going to be asked for exact trig values for sine of, let's say, 5 pi over 6. So to convert that to degrees, we would cut out the pi, multiply by 180. So 180 times 5 over 6 means it's a 150-degree angle. If you draw that angle, like we usually do, where this is the initial side, this is 0 degrees, this would be 90. 150 lands us somewhere over here. Okay, and so what you should do is you should make a triangle that makes a right angle with the x-axis. This is to help us calculate a reference angle. You might have heard that through some readings or through some other questions. The reference angle is this angle that's made with the x-axis. So we started at 0 degrees. We said 5 pi over 6. That's 150 degrees. And we know that a semicircle would be 180 degrees. So how many degrees are supposed to be left over here? All right, it's got to make 30. That way 150 plus 30 makes 180, makes a semicircle. So that's our reference angle, 30 degrees. And from those triangles that we memorized at the beginning, we know that 1/2 is always opposite of 30. And we know that this has to be 60 so that the triangle adds up to 180. And that means square root of 3 over 2 is across from 60 degrees. But you don't really have to have the whole triangle filled out because we can answer the question here. Sine of 5 pi over 6. We've drawn the triangle that represents that radian measurement. And now we can do right angle trig using our reference angle. Sine is the opposite divided by the hypotenuse, which is always 1 with this approach. Okay, because we're drawing the triangles in the unit circle. So sine of 5 pi over 6, that's 1/2. Let's do cosine 5 pi over 6 while we're here. Okay, I should have put a label here, a negative sign, right as soon as I drew it, because look, on the x-axis, this is like 1, 0, right? Because we're doing the unit circle, so we always have a radius of 1. This up here would be 0, 1. This over here, if we were to keep rotating, make a semicircle, this would be -1, 0, because we're on the negative side of the x-axis. So we got to label that as a negative square root of 3 over 2. Because cosine of 5 pi over 6, looking from our reference angle, the adjacent side is negative square root of 3 over 2. And the hypotenuse is 1. So it gives us negative square root of 3 over 2. Maybe one more. How about, we haven't done tangent yet. Yeah, let's just go back. Tangent pi over 3. That would be 60 degrees, right? And actually, we can just draw it on the unit circle like we've been doing. Tangent of 60 degrees, that's somewhere in the first quadrant. If this is 60, then we said square root of 3 over 2 is always opposite of 60. And so now we can do right angle trig using 60 degrees. Tangent is the opposite divided by the adjacent. So we got square root of 3 over 2 divided by the adjacent. So you got to flip and multiply that second fraction. And if you do, the 2's cross cancel, we're left with square root of 3. So the tangent pi over 3, that's square root of 3. I hope this gives you an idea of like what they mean by exact values. We need those square roots of 3, the square root of 2 over 2, all that stuff in there, not decimal approaches. And it's really about drawing those triangles in the x and y coordinate system and then thinking about those reference angles.